welcome to day 2 of tangent and secants, and let's look at a couple pictures and let's identify what's a secant and what's a tangent. So if I were to look at this first example and I was to look at B to C, would that be a secant or would that be a tangent? Well, recall that a tangent only touches a circle at one point. So it's not going to cut through the circle, because if a line goes through the circle, it hits it in two places. So BC is my tangent. And AC or CA is my secant. So we're going to learn a special relationship between the lengths of this tangent and this secant in a circle when they are adjoined at one exterior point. Exterior means outside. All right, so we'll call this case 1. In case 1, the relationship between the side lengths is going to be determined by a formula. So let's put some, I'm going to use variables other than A, B, and C. So I'm going to use X, Y, and Z. So I'll call this length BCX. I'll call this length from this point on the circle to the exterior point on the secant, I'll call that Y. And then the length from all the way from this point on the circle to the shared point, so the whole length of this secant from this far distance on the circle, we'll call that Z. So there's a relationship between those lengths. And the relationship is, if I square the tangent's length, it is going to be equal to this distance on the outside of the secant, so from this outer point to the joining point, so this short outside distance, Y, times the whole length of this secant from this far point all the way to the adjacent point, so I'm calling that Z. Okay. So the tangent's length squared is equal to the outside of this secant times the entire length from there to there. Okay, so we're going to use this formula in a minute. So that's tangent secant. Let's come over here and look at this picture. Do we have a tangent? I don't have a tangent drawn because a tangent can only touch a circle in one point. So these are two secants. So this is secant. This is a secant because look, it goes through the circle. There's a chord right there. It makes a chord in the circle. And this is a secant. So we've got secant. Okay, there's a relationship between the lengths of these secants when they are intersected at one point on the outside of the circle. And we'll use this formula also to find these lengths. So I'm just going to go ahead and put some points back on here. And I'm going to label them. I'm going to use A, B, C, D at this time instead of the X, Y, Z. So this distance from this point to the point of intersection, I'll call it distance A. So the distance. And then from this outside point, so the length of the secant, just like this, how I did the outside of the secant and the length of the secant, I'll call that B. I'm going to do the same thing with this bottom secant. I have this distance right here, the outside, I'll call that C. and then the whole distance, I'll call that D. So there is a relationship between those lengths, and the relationship is fairly simple. It's that outside length A times the whole length B is going to be equal to that outside length C times the whole distance D. So that's the formula we're going to use when we have secant, secant, and we'll call this case 2. We'll call it secant. Yeah, I'm spelling. And then over here, we'll call this tangent secant. All right, here's the kicker. A lot of times they're going to give you this outside length, and then they're going to give you this inside length. So we have to find the whole length. Well, if we have to find the whole length, don't we just add this outside and this inside together to get the whole length? So keep that in mind as we go into our first examples, and we're going to start with case 1. Okay, case 1 is tangent secant. And remember that formula, if you look up at your paper, is the tangent squared is equal to the short distance on the outside times the entire distance. Well, the first thing I want you to notice is that I don't know the entire distance here, and I need to know this entire distance. Well, let's say that this was the number 7. If it was a 7, then I would go 7 plus 18, and I would know that entire distance is 25. But I don't know this. So I know this entire distance is x plus 18, because it's this piece plus that piece. So I'm going to write that. I know that is x plus 18. I don't know if you can see that, so we'll do it in blue. Okay, so there's my formula. It's going to be this outside times the whole thing, so it's going to be 18 times x plus 18. So the outside times the whole length. And how did I get that whole length? I added this piece with that piece. That's why it's x plus 18. And that is equal to the tangent squared. Okay, so I have to use my algebra skills here, and I know that I need to work inside the parentheses if I can. I can't add that x and 18. So now I'm going to distribute this 18 in. So I get 18x, and you can use your calculator for the big numbers. You don't have to do that in your head. You have calculators. So we have 18 times 18, and I get 324. So I went 18 times x, 18 times 18 equals, and then 30 squared, and you can do that in your calculator as well. Now I just have a 8th grade equation, two-step equation that I'm going to solve. I'm going to subtract 324 from both sides. So over here I get 18x. And over here I get 576. Now think about what you do in that last step. I need to get the x alone, I need to isolate it, so I'm going to divide both sides by 18. And I get 32. So this length here is 32. And I can check it. I can see if 32 plus 18, which is 50, times 18 is going to give me 900. So I can plug that back in and check it. All right, let's try another one. So here they just wanted me to solve for x. Here they want me to find this distance here. What do I know? I know that this short side times the whole thing is equal to the tangent squared. Well, I don't know the whole thing just yet, but I know the whole thing is this piece plus that piece, so let's look and see what that is. I'm going to do that math up here. So I know it's going to be x plus 6, because that's this piece here, plus 9. I need to combine my terms for that. So that's x plus 15. 6 plus 9 is 15. So this whole outside distance is x plus 15. Okay, so let's remember, this square, the tangent squared, is equal to this short side times the whole thing. And that whole thing is x plus 15. How did I get that? It's 9 plus the x plus 6. Okay, so let's do that. The outside, which is 9, times the whole thing, which is x plus 15, is equal to the tangent squared. So I'm going to go ahead and distribute that 9. Use your calculator. So I get 9x plus 135 equals 225. And I'm going to solve it, just a basic two-step equation. So I'm going to subtract 135 from both sides. Over here, you're left with 9x. And over here, you're left with 90. So when you divide by 9, you get 10. But that's not the question. It didn't say solve for x. It said find km. So I have to put this 10 back in place of this x, right? So 10 plus 6 is 16. So I know this distance right here is 16. And that distance right there is 9. So km is 16 plus 9, which is 25. Okay, so that was case 1, tangent secant. Now let's do secant secant. Okay, let's look at case 2, secant secant. Now, the formula is still kind of almost the same as the tangent secant. Well, it is in regards to the secant. Remember with the secant and the one with the tangent, it was the outside times the whole thing. Well, we're going to use that same thing. It's going to be outside times the whole thing is equal to the outside times the whole thing. So remember with the secant, you're always using the outside times the whole, the outside times the whole. And with the tangent, you're just squaring it. Okay, so it's really not that difficult. But I don't know my whole right here. But I know it's whatever this is plus 7, so we'll call it x plus 7. It's whatever that number is plus 7. This whole, well, that's easy. 13 plus 8 is 21. So I'm going to solve for x. And I'm going to use my formula. So it's going to be 7, the outside, times the whole thing, x plus 7, is equal to the outside, 8, times the whole thing, 21. So I'm going to solve it just like I always do. I'm going to distribute, so I get 7x plus 49 equals 168. And then it's just a regular old two-step equation. And I'm going to subtract 49 from both sides. So I'll go in my trusty calculator. Mm. 168 minus 49. So 7x equals 119. So now I'm going to divide by 7. And I get x equals 17. And I'm done because that's what the question asked me to do. The question asked me to solve for x, so I finished the problem. So remember, it's secant, and secant is outside times the whole. All right, so let's look at this one. I need outside times the whole, outside times the whole. Well, I don't know the whole of either one of these. By the way, it's not asking me to find x, it's asking me to find mk. So I'm going to have to go back and plug that in when I'm done. But let's find our whole pieces first. So this whole piece is 10 plus 3 plus x. It's 10 plus 3 plus x. So this piece plus this piece. So it's 13 plus x. 13 plus x, because it was this piece plus this piece. I'm going to do the same thing here. This piece plus this piece. So it will be 9 plus 2x plus 1. Well, these two can be added together. So it's 2x plus 10 because 9 plus 1 is 10. So this whole piece is 2x plus 10. 2x plus 10. Okay, secant is outside times the whole thing. So I'm going to go outside 10 times the whole thing, which is 13 plus x, equals outside, which is 9, times the whole thing, which is 2x plus 10. You're going to have to distribute, and then we're going to have x's on both sides. So I'm going to get 130 plus 10x equals, I distribute that 10, 18x plus 90. Now the way I taught you guys is that we always subtract or get rid of or manipulate the smaller x because I have x's on both sides. So I'm going to take 10x off of both sides. I'm going to subtract 10x off of both sides. It's going to make that go away, and I'm going to have 130 equals 8x plus 90. So I subtracted 10x off of both sides. Now I'm going to subtract 90 from both sides. I don't have enough room, so I'm not showing you, but I'm telling you I'm subtracting 90 from both sides. Should be 40. So I get 40 equals 8x. Now I'm going to divide by 8, and that's 5. We're not done. We did all this work, a lot of work, and that's not the final answer. Because the question is asking about from M to K. Well, from M to K, that distance is 2x plus 10. All the way from M to K was 2x plus 10 because that was 9 plus 2x plus 1. So I'm going to substitute 5 in place of there. So 2 times 5 plus 10. Well, 2 times 5 is 10 plus 10 is 20. So MK equals 20. Okay, so make sure that you watch the video again if you need to. Summarize what you learned and write at least one question that you have.